All right, guys, we are working on page 23 and 24. We are going to look at, we've now worked with expressions that are already written for us. We understand how to simplify them, even if distribution is involved. We can write an equivalent expression that is simpler. Now we need to look at writing our own expressions. The expression is not given to us. We want to come up with it. So get out page 23, pens and pencils ready to go, and let's learn about writing expressions. On the top, it says this in the gray box here. Consider the following. Maria found a shirt on sale for 25% off. Has that ever happened to you? Discounts, sales, when you see those signs, do you know what they mean? Do you know how to do the math behind it? Here's what it says. Answer the following if. I would like you to take a pen or a pencil and circle this with me right now. X represents the original price of the shirt. What does that mean, original price? Well, it means the price that's actually on the price tag. How did the store originally set the price? What was the price before there was a discount? Okay, so X, why are we calling it X? Well, because it is an unknown. It is a piece of information in this problem that they did not tell us. We do not know it. All we know is that the shirt was on sale for 25% off, but we don't know what it originally cost. So question number 1 says, how much of the original price will Maria have to pay for the shirt? We're going to come back to that. Let's jump to number 2. Write an expression that represents the discounted price of the shirt. Our expression is going to start with X. Because if you were calculating this, you would first need to know the original price of the shirt, and that is what X represents. Now, we also talked a lot in class, and we'll talk a lot more as we move forward in class about the different forms of percents. Hopefully, at this point, we recognize that 25% is actually 25 out of 100, because percent means out of 100, which can also be said as 25 hundredths, which means it can also be written as 25 hundredths in decimal form. So 25% is really 25 hundredths or 0.25. All right, now that matters because if we take the original price of the shirt, this is a discount, so we're taking money away. How much are we taking away? Well, we don't actually know how much until we know the price of the shirt, but we know it's 25% off of what? The original. So if I do 25%, and a lot of students want to leave it right there. They want to tell me that it's the original minus. Now, if I leave it like this, I need you guys to recognize that if I just write 0.25, that is not a percent. A percent is a portion of something. If I leave it like that, and I'm talking about money, I'm saying you got 25 cents off the shirt. Is that what happens? Did you get 25 cents off? No, you got 25% off. 25% of the original. This, putting this X multiplied on this 0.25 dramatically changes the meaning of this expression. What this expression means is original price minus 25% of the original price. Well, isn't it true that this really means 1X because it's one shirt, so one original price? And aren't these like terms? So can't I subtract these things because they're like terms? I can subtract these coefficients. 1 minus, you may not need a calculator for it, but just to prove to you where it's coming from, if I subtract those coefficients, that means 0.75x. This is an excellent expression, and this is just simplified. So that's what they mean by write a second expression that represents it, and that actually leads us back to question number 1. If it's 25% off, how much are you actually paying? Well, you're actually paying 75% of it, which is why this turned into this. Today is all about expressions, working with expressions, writing expressions, recognizing that the mathematical symbols in the variable expression still have to hold the same meaning as they do if you had all numbers. So to practice this and make sure we have some background knowledge on this, right here it says, for each context. The word context means some kind of story or situation. 4 algebraic expressions, that means there's variables in them, are offered. Make a conjecture. Oh my goodness, so many fancy words in here. Conjecture means guess, an educated guess. Make a conjecture about the correctness of the expression. In other words, do you think it's right? Take a guess, yes or no. Okay, so we're gonna start with that. You guys are gonna do that part because I can't guess for you, that's all you, all right? So right here, number 4 says, here's the context or the story. Ryan bought 3 CDs for X dollars and a DVD for $15. The question is, how much money did Ryan spend? And that question tells you what the expression is supposed to represent. So you're supposed to tell me, take a guess right now, a conjecture. Do you think this expression correctly represents this context? Write yes or no right here. It's just a guess, no stress. You guys write yes or no. Take a guess. Here's another expression. Make a conjecture. Write yes or no in this box. You should be doing that right now. Yes, I think this expression works, or no, I think it doesn't. Guess on this one. 15 plus x plus x plus x. Yes or no? Yes, it works. No, it doesn't. Does it match this story? That's what you're guessing. And this last one. Yes or no? So you should have this column filled in. That's just you. You're guessing. Do you think it's correct or not? Now we're going to use this column to find out for sure if you think it worked or if it actually worked. So let's say all of a sudden I'm telling you the unknown. So what am I telling you? I'm telling you the cost of each CD. That's the part we didn't know. He bought 3 CDs for X dollars. We don't know how much those CDs cost. Okay, we know he got 3 of them, and we know the DVD was $15 because a DVD means he only got 1. This is the only part we didn't know, and now all of a sudden I'm telling it to you. So we're going to plug that value of X into this expression. We're going to find out if your conjecture was correct. 3 plus 7 plus 15. This one is going to be 15 times 7 plus 3. And I should give myself room for an answer. This one is going to be 15 plus 7 plus 7 plus 7. And this one is going to be 3 times 7 plus 15. Now let's actually evaluate these and find out what the answer tells us. 3 plus 7 plus 15. Okay, 3 plus 7 is 10, and 10 plus 15 is 25. If this expression is true, then Ryan spent $25. Does that answer make sense? I don't know, let's check some other ones. If this expression is true, 15 times 7, well, I do 10 times 7 is 70. 5 times 7 is 35. 70 plus 35, that's 105 plus 3. That is a drastically different answer, which tells me one of those two is certainly not correct. They can't both be correct. You can't go in a store and be like, I want 3 CDs and this DVD, and have one time they say $25 please, and one time they say $108 please. You'd be like, wait, what? Something's not working here. Okay, let's look at this one. 15 plus 7 plus 7 plus 7. Okay, I'm going to do this part first. 7 plus 7 plus 7 is 21. Plus 15 is 31 plus 5 is 36. Okay, so far I have 3 different answers, so these definitely can't all be correct, so I got to figure this out. This one, 3 times 7 is 21 plus 15 is $36. Okay, that's starting to suggest something to me. First of all, what I know is that these two are equivalent. Did you guys recognize that as you were looking through there? And this verifies it. They truly are equivalent. Which answer makes sense here? How much money did Ryan spend? Does this one make sense? No. Does that match your guess? Does this one work? No, that is way too much money. That doesn't make any sense. Looks like these two worked. And over here, we're supposed to give an explanation as to why. So if I'm looking at this one, the real problem with this expression is the addition right here. If you bought 3 CDs for X dollars each, you need to have multiplication, right? Multiplication is what makes sense there. So if I'm looking at why that didn't work, well, because 3 plus X would mean $3 plus 1 CD. And that's not what happened in the story. It was 3 CDs, right? So 3 plus X doesn't work in this scenario. Does this one work? No, because 15X would mean 15 CDs. And again, that's not what happened in the story. You didn't buy 15 CDs. Okay. Does this one work? Yes, because $15 was the DVD, and X plus X plus X is 3 CDs. So that's the correct representation. And why does this one work also? Because the $15 is the DVD, and 3X is just another way of writing X plus X plus X, so it still represents the 3 CDs. So these two expressions match this story. These two expressions did not. All right, let's try this one more time. We're throwing a percent into this one. They're going to be a big deal with our expressions. They're a big deal always because they're part of rational numbers, huge part of our number system. We got to know how they work. So let's check this out. Number 5. Kim bought a binder for $5. And remember, at any point, if you're like, I didn't write that all down, Ms. McGowan, I'd pause me and get it all written down. You can always pause me. I'll wait. Kim bought a binder for $5 and 4 notebooks for N each. All of the items were on sale for 50% off the original price. Make your conjectures right now. This is the part where you're just guessing. Do you think this expression matches the story? Do you think this expression matches the story? Write yes or no in that box. It's just a guess. Nothing's going to happen if you're wrong. Do you think this one matches the story? Yes or no? And what about this one? Did you make your guesses? Because now we're going to find out. I'm going to tell you the unknown. Here was the unknown in the original story, N each. I didn't know how much the notebooks cost until right now, until I just told you. And I told you so that we could evaluate and check it out. So this one's going to be 0.5 times 5 plus 4 plus 3. I'll work that out in a second. 0.5 times 4 times 3. That's the 4n right there. It means 4 times 3 plus 5. This one is 1/2. 5 times 3 and 4 times 3. Okay. This one is 1/2 of just 4 times 3 plus 250. All right. Now let's actually evaluate these. So I'm going to do parentheses first. 5 plus 4 is 9, and then 10, 11, 12. And what does this 0.5 do? It takes half of it, because 0.5, as we know by now, 0.5 is equivalent to half. So if I have 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I'm just going to do half of it times by 0.5, half of 12 is 6. So $6, does that seem right? I don't know, let's keep going. 4 times 3 first. I need to do the parentheses first, yes, but within the parentheses, I also need to multiply before I add. So 4 times 3 is 12, 13, 14, 15, 16, 17, and then half of 17 is 850. Notice I put a 0 on in the end and a $sign because that's how money works. All right, this, I'm going to multiply these. 15 plus 12. You get that? 15 plus 12 is 27, and then half of 27 would be 1350. Oh, goodness gracious, I have all different answers again. What is going on here? Okay, and this one, I'm going to do these parentheses first. 4 times 3 is 12. Now, that's not in the parentheses, so I need to do half of that first and get 6 before I add the 250. And now that's $8.50. So like before, these ones are equivalent, and they're also the ones that work. They're the ones whose answers make sense. Let's look at why. Okay. Why did this one not work? And that may or may not have been your guess. It's fine, you know, no. Why didn't this one work? Right here, this is 50%, so that's fine. That makes sense. Because everything was 50% off, so that makes sense. However, again, right here, this addition is the problem. If I put 4 plus N, I'm saying it's $4 plus 1 notebook. And that is not at all what happened in the story. They didn't say $4 plus a notebook. They said 4 notebooks. So it doesn't make sense to add that right there. That's only 1 notebook. We know there were 4 notebooks, so our expression needs to show that. Do we all understand that? That's only 1 notebook. No good. Okay, why did this one work? Well, the 0.5 is 50%, so that's important. Inside the parentheses, the 4N shows 4 notebooks, which is precisely what happened in the story. There should be 4 notebooks in the expression because there were 4 notebooks in the story. And the 5 is the $5 binder. Everything in the story is represented in this expression. And the expression shows the correct order of operations. It shows that I would do 4 notebooks and calculate that first. Then I would add the $5 for the binder. And then after I put all that together, I would take 50% off of all of it. So it not only shows everything represented from the story, but it also shows the correct order of operations. That is a very key and important part when you're writing your expressions. Why didn't this one work? Well, because it said 5N, which would mean 5 notebooks, which was not a part of the story. So that doesn't make any sense. Don't write 5N when there's not 5 notebooks. N is for notebooks, or cost of the notebook, okay? Here, this one worked because 250 was already 50% of the binder. It's kind of an interesting, different way to write it, but it does work because you're already taking 50% of the binder. Okay, all of this on the front was really just to double check. Do we understand that there are different representations that can work, but that doesn't mean every representation works? Okay, so I started you on this side by giving you some expressions and finding out if they worked. Now, as we go to the back, we need to try and get good at writing our own expressions. And the #1 step there is right here. So everybody flip over to page 24 and be ready to write some more with me. This is always step 1. You first have to decide what's the unknown here. And I'm here to tell you right now, there's more than one usually, but you have to find like the key to finding everything else. If I knew this one thing, I could answer this question. If I knew this one thing, I could calculate it. So right here, #6, Carlos is paid by the hour. He works for 20 hours and earns $50 in tips. Let's say I wanted to know how much money Carlos makes. Yes, that would be the unknown, but it's also my answer. The question is, if I want to know how much he makes, what's the one piece of information I need to know and don't know? Well, I know he works for 20 hours, so I know how long he works. I know he makes some money in tips. Do you know what I don't know? I don't know. I'm going to call it X because it's an unknown. I don't know money earned per hour. That's my big missing key. If I knew, it says Carlos is paid by the hour, but it doesn't tell me how much. If I knew he made $10 an hour, then I could find out his earnings. I could go 20 times $10 per hour plus the $50 in tips. But the unknown is money earned per hour. My water's so far away. Okay, #7. Angela goes to the store and buys, there should be an S there, 10 pounds of apples. What's the unknown here? 10 pounds of apples. What do I not know? What if I asked you how much money did she spend? What would you need to know to find that? How much money did she spend? I need to know the cost of apples per pound. This step is essential to writing an expression. And in fact, we're now going to take it a step further. That's all those questions wanted. Now we're going to do a little bit more. Now we are going to determine the unknown in each scenario and use it to write an expression. This is a little trickier, and we're going to take a couple days to make sure we're good at it, but starting right now, we need some examples. Okay, again, the unknown. Determine the unknown. That's step one. Alex earns $12 per hour. Okay, that's important. And he received $25 in tips last night. Write an expression for the amount of money he earned in H hours. Holy cow, they kind of gave it away. The one thing I need to know in this scenario, that's my key to finding out everything, is, they already called it H. Let's write it down. H is number of hours worked. Once I have my variable, then I focus on the order of operations and make my expression match that. If it says $12 per hour, I would do 12 times the hours, and then after that, I would add in the tips. Think about what would make sense in your calculation and then set up your expression to match the order of operation that makes sense. $12 per hour times the number of hours plus the tips. Let's try it again. Brandon bought 5 apples for 75 cents each and 5 oranges for, well, there it is. They're kind of giving them away right now, X dollars each. The unknown is cost of each orange. Write an expression to represent how much money Brandon spent. Think of the order of operations that makes sense here. If you were calculating this in real life, you'd say 5 apples times 75 cents each, and you would add to it, because it's a total, plus 5 oranges times whatever they cost each. There we go. There's an expression. I could multiply those if I wanted to, because they're both numbers, but this expression represents the total cost of the fruit that Brandon bought. Stick with me here. We're going to practice this a lot, so keep going. Number 10, at the farmer's market, the cost of an acorn squash is 75% of the cost of a pumpkin. If you buy 8 acorn squashes, write two expressions to represent the cost of your squash. Okay, what is the unknown here? Actually, I don't know the cost of the squash, right? But that's what my whole expression is going to represent. So that's not my main unknown. What would I need to know the cost of the squash? That's the key here. What would I need to know the cost of the squash? Well, I would need to know the cost of the pumpkin. So I'm going to say, you can use X every time, or you can mix it up. I'm going to say P equals cost of a pumpkin. If P is the cost of the pumpkin, guess what? Order of operations. I'm going to do the pumpkin. The cost of an acorn, it's 75% of the pumpkin? Okay, 75% of the pumpkin. And I'm going to buy 8 of them times 8. Make your expression match the problem. Now they want 2. Cost of an acorn is 75% the cost of a pumpkin. Well, I'm going to stick with, we're going to leave it at 1, because I think sometimes when I show you guys the other one on that one, it gets a little murky. So we're going to stick with 1 on that one and move on. Number 11, when a company buys a product, it will mark the price of the product up by 35%. Write 2 expressions to represent the new selling price of the product after the markup. I'm going to give you a hint right now. We're going to work on these a lot over the next couple of days. When they start talking about marking up or discounts or anything, your unknown is always going to be, what was the original price? Before we did anything to it, what was the original price of that thing? Okay, so they mark up the product. What that means is they take the original and they add 35% of the original. That's one way to write this expression. A second way to write this expression is to do exactly what we did on the front, where you combine like terms. 1x plus 0.35x is 1.35x. There's one expression, there's another expression. Okay, we are going to practice this a ton more, and we will actually come back to these last two examples as kind of like a, hey, come back to this tomorrow and remember what we're doing. So this will be how we'll start the next video next week to make sure this is still in our brains. So leave those last two. When you take your pictures and upload your notes, I'll know that these last two are supposed to be blank. We're gonna practice a little bit of writing expressions on, they're already written for you. You just have to pick the right one just to kind of get our feet wet with this because it is a little complicated. We will, when you take your two pictures, I'll know these last two are blank and we'll come back and finish those next week.